All right, everybody, welcome back to Room AB for our 2:30 session. I want to thank our sponsor, WithSecure. WithSecure Consulting is at the forefront of safeguarding organizations globally, recognized for their commitment to excellence and research-led approach. They are the trusted partner for companies where cybersecurity is not just a priority, but absolutely business critical. I want to introduce our two speakers, Nathaniel and William, who are going to talk about detecting cloud threats with dynamic clouds. Welcome to the stage.
All right. You can hear me all right? Fantastic. Thank you so much for Forward Cloud Sec for allowing us to present this talk. This is something that's both very near and dear to William and I. We both love kind of this active counter defense sort of aspect. How do we actively defend our cloud environments? And what better to do that than with honeypots, right? All right, so a little bit of who we are. I'm going to start with William Gamazo. He's a senior principal researcher. A principal threat researcher with here at Palo Alto. We both work at Palo Alto, Prisma Cloud, Cortex, and Unit 42. Everything that we publish does go through the Unit 42 channel. We are focused on the who, why, and what behind cloud threat actors. We're threat intel, threat hunting, RE, incident response, SOC operations background all over the environment. We have lots of fun interests. William plays chess. Any like avid chess players? I mean like expert level avid chess players. I will never touch him. Just like, whoa, destroy me. All right, so our agenda today is we're going to detect these nasty little waspy bees, and we're going to try to trap them in our little honey clouds. So we're going to talk about basically what is our honey cloud, a little overview on that. William's going to talk about P2P infect, Electroleak, and some ransomware that we've found, and then a little bit of takeaway. So first off, our honey cloud. Essentially a honey cloud, take your traditional honey pot and you take it with a dynamic scaling capability of the cloud environments, and then believe it or not, you can come up with a honey cloud. Our honey cloud attacks roughly about 200 attacks an hour, about 1,700 some attacks a day. We are able to actively and dynamically deploy across different CI/CD pipelines. We look at GitHub, which we'll talk about here in a second. We do repos to clouds, cloud lateral movement, cloud privilege escalation, a lot of those aspects. Current blog that we have in pipeline, which will come out here in about a week or so. It's all about ransomware in the cloud. They're not they're not charging like millions of dollars per ransom. It's like 10,000 because of the scale that they're doing it, which is pretty interesting. This is a diagram of our honey cloud. It looks pretty fun, right? There's a couple little bits over here. The important bit that we have is going to be this big section right here. This is our operations account. Inside of this operations account, we have our Cortex, basically a SIM operation. We've had Elk Stacks and Splunk and different kind of pieces in that. We do have Archime, so it's doing a lot of PCAP sort of UI generation. Which is being fed by each one of our little honeypots. Our honeypots have two different types of monitoring system on them. We have a custom eBPF agent, and as well as our Cortex EDR agent, as well as T-Shark that is reading everything outside of those particular. Basically, this is in a AWS environment, so this is an EC2 host. It's a Docker host that has a particular application or multiple different containers inside of it. Our monitoring apps are inside of their own little container inside of each one of these hosts. Everything is run by Terraform, so we can actually just spin up and throw apps in any region, anywhere we want to go to inside of AWS, and we can do it dynamically and on the fly. I'll show you just a second. The bread and butter of the honey cloud is this, something we call it the dynamic honey cloud account, where we can throw up brand new AWS accounts, tear them down, throw them back up, tear them down, throw them back up. We generate identity and access management credentials in here, plant those inside of our honeypots, and then throw them wherever we want, and then record those actions to see what's happening. Everything that we have, every single account is fed through S3 bucket. So we get all of those CloudTrail accounts, all of those configs. Anywhere in this environment, they automatically go through. They are mirrored across our operations account into a secure operation, so we never have to worry about losing logs or anything of that nature. We're always recording So even if a threat actor gets in here and just kind of like blows things up, we can still record everything and we don't lose anything, which is great. Here's an example of Terraform. So on this side here, this is an example of the different regions that we're going in through. You can go ahead, take that cred, we'll just, or that ID, and we'll just remake it after today. So there you go. Go poke around, see what's in there. Over here, these are the actual individual honeypots themselves. You can see we have like JMeter, Confluence, Docker, Docker registry. Our Docker is really fun. We're actually doing Docker inside of Docker. So we have a Docker container running Docker containers. And that way we can see if they're doing container escapes, they're doing things of that nature. That's really an awful lot of fun. The cool thing about our Terraform is all we have to do is turn this enable to false and then hit Terraform apply, and then all of those containers turn off. And then we can change the region that we want to put them onto, turn it over to true, and then hit Terraform apply, and then all of those containers spin back up. So pretty impressive. A little bit about what our traffic looks like. It's pretty nice. So you can see here that we're looking at URLs right here. All of the URL traffic that we're getting outside of those containers, we can see exactly who's hitting it, when they're hitting it, which is pretty nice. Another little piece here. We can get all of the operations, the runtime operations that are happening outside of that. Now this is outside of our Cortex EDR. We wanted to be a little bit more user-friendly, so this is a Splunk look on this particular aspect. Yeah, so you can use anything that you can take those. We're pulling everything from IPs, domains, user agent strings, hash values, running through all of that. There's one piece that I want to look at right here, which is very important. We have something called a goodware database. We all know about malware. We decided we want to do a goodware as well. So everything that's supposed to run, golden image inside of a container, we want to record all of those hashes and record all of those functionalities. And then every single process that comes through our either our Cortex EDR agent or our eBPF agent runs through the goodware database, so we can eliminate all of those known goods, and that way it helps us triage, and we don't have to spend a lot of time doing things that are benign. All right, I'm going to turn it over to William, and he is going to talk about P2P infect.
Okay, everybody can hear me? 1, 2, 3. It's okay? Okay. So as we mentioned before, the honeypot that we have is very dynamic. So one of the challenges we have with honeypot, you are exposing cloud indicator like a cloud key, cloud AWS account. Once the attacker get that information, if he finds that it's not useful, he won't use that account anymore. So one of the challenges that we have is how to create a honeypot environment where every time that you create the honeypot environment, everything is new. So you are forcing the threat actor to go again and to see if that environment that has some vulnerability is interesting or not. That is the challenge of this honeypot. That is why it's so dynamic. So once we shoot down everything and we create everything again, everything is rather new. You don't know. You have to test manually if it's interesting or not. Another important thing to understand is we are making everything that is created in that honeypot is inside containers. So it's server side. One part of the honeypot is server side high interaction honeypot, and each container is vulnerable to only one vulnerability. So, for example, I'm going to explain this. I'm mentioning this because I'm going to explain this finding, the P2P infect. P2P infect is a P2P malware. I think it's the first peer-to-peer malware very well designed that you can find in the wild. So it can communicate itself, it propagates itself, and when it propagates itself, it communicates over the peer-to-peer network. So even during the payload delivery, he is propagating through himself using the peer-to-peer network. We'll see one example of that. So this P2P infect, we found this during the deploying of the honeypot container vulnerable to 22.05.43. Why this vulnerability? So once we decided to have one container per vulnerability, we have like three kind of Redis container. One Redis container vulnerable to conflict redirection, one vulnerable to master late replication, and one vulnerable to DCP. These are unique containers, very well configured in a way that they are vulnerable to each of one. The interesting part about the CVE that you will see there is that the CVE is not a Redis vulnerability. It's a package managed vulnerability. So you cannot reproduce that compiling the Redis source code. Because this vulnerability is very specific to some configuration, to some system. And we found that wasn't being exploited in the wild at the time that we were creating this. It was mentioning some exploitation, but not in mass exploitation, as we saw the other two at the beginning. So we decided to create a container with this specific vulnerability to see, because we are expecting some very well-designed attack targeting this CVE. We did that just in a couple of weeks. We got the P2Infect infection. This is the payload of the P2P infect. So the P2P infect uses that CVE that I mentioned before. It's using a technique of the TCP device for communicating. Actually, you will see that IP and that port is the payload. That payload is actually communicating back with another infected P2P module. And the P2P module is being installed in another machine, which is already compromised. So this infection is peer-to-peer infection. This is what the payload is doing. This is how look the events inside a honeypot. So as we mentioned before, the honeypot has a custom agent. And that custom agent, what it's doing is capturing all the information about the behavior in the machine. And one very nice feature of that custom model that we created is they capture the sample automatically. So once it found some binary drop in the system, it will compare the binary to the good DB. If the good DB is not in there, it will report the sample back. So we have automatic capture, not only the event and the states, all the feature, all the, you can say, behavior of the container. Also, we have automatic sample recollection in that event. Also, we have another interesting feature that has this one is the mapping of the place where the infection happens. You see at the bottom, the event source, they have the intent ID. Actually, this is the AWS intent ID where happened the infection. We have the public IP of that machine. We have the zone. We have every event is correlated to every place, to every exactly container that happened just by the event. So when you have that information, it's very easy to identify new alert and new attacks, you can say. This P2P infect malware is very active today. This is not history. It's happening right now. And at the time that we captured him, it was very nice because it was at the beginning of the developing of the malware. So the module, because they have the main module, and then he communicated to download more modules. At the time, it was 3 more modules from Windows, Linux, and another one which is not related to the platform. At that time, the module doesn't have, at the time that we discovered this, the module doesn't have any functionality. It was empty binary. So when you open the binary to reverse it, they have empty because they were just beginning to develop the malware. Right now, this P2P infect is very active. The modules are better. One of the actions that we saw very often, very aggressive, is scanning for environment files, leak environment files. We'll see that what happened in the last with the last finding that I have. Very aggressive. So we even AWS is requesting us to shoot down some of the machines once we get infected with this P2P malware. Let's talk about the next finding. The next finding, so remember, the P2P infect is using the high interaction server-side exposure and vulnerability Honey Cloud. This electrically is another module in the Honey Cloud, which is exposing AWS secrets through different mechanisms. And this module of the honeypot is a little bit different to that one, but it's very nice as well. So the idea is to leak information about the cloud, whatever you can think of. Any idea is welcome to leak information. You can leak services, you can leak whole services, you can leak AWS key, you can leak other kind of credentials, roles, whatever you want to leak. And it's important to determine what are your leak points. The leak points can be any kind that you can imagine. We started very simple. We started with GitHub and Bitbucket, which are the easy one. And we know that they were targeted by attackers as well. So you can leak, for example, the AWS key in plain text in base64, different way, in different kind of repo. You can even leak the same key. If you are using repo, you can leak the key in past commits. You can leak the key in non-defined branch. You can leak the key in the main branch as well. So there are different ways to leak that information. And when you leak information, there is two actions that happen. Either you are being targeted for someone, or you are being targeted for some automation. And when we found this, we found a lot of automation. We still have today a lot of automation discovering those keys and attempting attacks. So this is the architecture. Basically what we did in this cloud key, this module that you see there is part of the whole architecture that we have. They have all the same monitoring system. And basically what we did, we randomly selected the GitHub repo, randomly, and we clone that repo and we leak the keys in different way, all the way that I mentioned. Once we have that, publicly we will see a threat actor collecting those keys and doing action in the AWS account. Something interesting that happened that we didn't know before when we were doing this is when you public a key, an AWS key in GitHub, GitHub has automatic scanning mechanisms themselves. And they report that key to AWS. And AWS, what do AWS is assign a policy to that identity. And that is a quarantine policy. I think everybody knows what is the quarantine policy. But that happened automatically. So for us, that was a bad news because when you assign a policy, the attacker can't do anything in the system, right? So what we did is we created a lambda function. We improved the lambda function that we already have for monitoring the cloud trade logs for reverting back that policy. So once the AWS assign the policy, we revert back the policy. And once that, the attacker can do whatever they want, right? But you may say, why are you doing this if AWS is already protecting you? Well, the funny thing is not, because that depends how you leak the key. If you leak the key, for example, in plain text, in the main branch, it will get found. But if you leak the key in a branch that is not the default branch, you can still find it yourself using a secret scanning tool, but GitHub is not going to be able to find it. That's also already fixed. And another thing is, at the time that we publish the key, if you publish the key in base64, also it's not going to be found. So there is some conditions where we publish things and this mechanism doesn't happen. But anyway, we revert back the policy for all the cases in case that happens. This is one example of the trade logs that happen in that case. We have the AWS internal is the AWS operation doing attached user policy, implementing the quarantine policy. We revert back, and then in less than 5 minutes, we get the action from the threat actor. All the get caller activity, get caller identity, describe instance types. All these actions are malicious actions.
Just to double click that real fast. From exposure to actual operation in the cloud, less than 5 minutes. So
yes.
Very fast.
And after we publish a blog, we have a meeting with Bitbucket. Bitbucket, because of this, they improved the secret scanning. And we have a meeting with AWS. They took some action as well to improve the mechanisms. And after we published this, we monitored this operation that was very fast, was crypto mining. So we got everything about the wallet information, and we start monitoring for a couple of months the activity of that wallet. And once that we publish the blog, the activity of the worker were down a little bit. I hope that we did something good.
20 seconds left.
And the last finding is the ransomware. It's not a worm. We think that it's a worm. It's a worm because the way that it's implemented. So in this case, this ransomware was a threat actor that was scanning actively for environment leaks, file leaks through scanning the whole internet. So we are going to show statistics. So basically, I have to go a little bit faster because no time. So I'm going to explain this part a little bit faster. So we have the attacker scanning for environment files and extracting all the information about the virus. So the interesting part here is we will be able to access the infrastructure of the attacker and collect all the information that he was collecting. With that information, we analyze all the information that he was collecting, and we did one.
Yep, that's it.
That's it? Okay.
Your slides were detected by AWS and pulled down, so you can try and pull that policy back, but it's not going to work. We got some time for questions. I've got a few on the phone, but if you've got a hand up, I'll come over to you. We got a couple of questions on open sourcing this Honey Cloud, or any plans to open source it.
Yeah, so the Terraform itself that we have, we still have a little bit of sensitive information inside of it. We're going to try to rip that out and then we'll release it. Unit 42 does have a GitHub repository, which does have a lot of really cool cloud sort of things. Jay right here created a really nice one called de-escalation, IAM de-escalate. But we're going to do that same channel, put the Terraform up there. So you can just throw out your own Terraforms, which would be great.
The less than 5 minutes between exposure to exploit, was that a one-time thing, or is it a trend?
Over and over and over and over and over and over.
But actually, the first one, we skipped the first one because what the attacker did was he created instance, VM instance with init scripts. So the first one, we shut down immediately to review the log, what is happening, because it was the first time that we published it. And then in the second time, we give it more time to the attacker to do things. And then we shut down the VM. We did not shut the VM. And then we analyzed, did forensics in the VM. We found all the activity that was doing with that VM.
All right, I got another question from the phone. How long would it take for us to download the project and run it ourselves?
The Terraform script itself is pretty straightforward. What will take the most time is setting up your whatever SIM, either your Elk Stack or your Splunk or whatever SIM that you're using. You're going to have to configure all of your eBPF agents to do that. So there's going to be a little bit of a load for you to start that, but building up the infrastructure is pretty straightforward.
Do you have problems with like denial of service attacks through like exhausting the spend on the account? Like basically just doing very expensive activities to make sure you spend all of the account's money and then as like a punitive measure for this activity?
All the AWS accounts that are created are under one organizational AWS account. In that organizational AWS account, we have restrictions. For example, we limit the type of VM that can be created.
Yep.
So we have certain policies that limit how much resources the attacker can spend in the cloud account.
There's one thing, please meet with me afterwards. I can tell you, we're using service control policies to limit the actions inside. So even though the actor thinks they have administrator access, they can't actually do anything. So we're doing things like that.
Just a real quick question. Do you have any thoughts on creating honeypots like this for customers? So like if you, say you have a bunch of customers that you service, and you know that some of them are more likely to be attacked by a real threat actor, like a nation state kind of thing, and you wanted to try and create infrastructure like this to see who might accidentally trigger their stuff specifically. Is there a way that you might go about setting that up, or does this do a good job of doing that?
You want me to answer that?
I don't have an answer.
Yeah, so I would say we're not releasing this for customers because it does take quite a bit of monitoring capability. Yeah. It can certainly be used for that. Put this in your environment and see who's attacking it, then prevent that in your environment. But it does take a little bit of skill and monitoring capability to do that.
Yeah, you have to be very careful. This whole infrastructure is disconnecting from Palo Alto. Palo Alto is not anywhere in that infrastructure. It's totally disconnected. It has to be.
Thank you for paying the bills, Palo Alto.
All right, I've got another question for the phone. Do you image and snapshot the images of the container/compute instances for further analysis? Yes. Or do you only pull host and cloud audit logs?
That is a good question. So all the containers have, in the container we are using a file versioning file system. So a file versioning file system, which is mounted in the container, it automatically saves, if you put a file inside, it will automatically do the snapshot.
Yep. So we're snapshotting like for every new change inside of the container. So
it's a file system level. It's another way of capturing information.
Thanks for this. Do you have any automation around creating GitHub users, GitHub accounts, fake organizations, that kind of thing? And will you be open sourcing that?
We have the automation. We have to decide if we are going to, but the whole automation is there. So we create AWS for use it for GitHub, Bitbucket, and GitLab.
There's a really good blog Sysdig, or if you're in the room, thank you so much for doing the Purple Urchin stuff, because that particular, thank you, because that was amazing. Purple Urchin is a really cool thing, and they automate GitHub, and they go through all that stuff. But there are processes, I'll make note of that. So.
All right, thank you, everybody. Thank our speakers. We're out of time. We got another talk coming up in a few minutes. Thank you for your time.